All right, the topic in Algebra 1 here today is solving two-step equations. And might not sound like the most glamorous topic or something that you want to spend too much time on, but it's probably something in the past that maybe gave you some problems. Maybe you had some problems with trying to find the answers, or you've never understood at all how to solve two-step equations. I think after this you'll have a little better understanding. So we're going to pick up from what we've been doing so far and get into solving two-step equations. And we'll explain what I mean by two-step equations. Now before we get into this too far, let's just have a review here. Now say I had an equation a minus 2 is equal to, I'll say 15. Now we've been talking about inverse operations. Now we said that addition and subtraction are what are called inverse operations. Inverse meaning one undoes the other, or in other words, one operation is the opposite of the other. So addition, the opposite of addition is subtraction, and vice versa. And the opposite of multiplication is division, right? And when I say vice versa, I should really, let's go back to this one right here. The opposite of subtraction is addition, and the opposite of addition is subtraction. Likewise, the opposite of multiplication is division, and the opposite of division is multiplication. Now we're going to use that concept here when we solve this equation that I wrote up here. So I'm going to highlight the variable, and so we want to solve this. We want to isolate A. I want to get A by itself. So to isolate A, we use inverse operations. So I'm going to ask myself, let's see, what's happening on the side of the equal sign that A is on? Well, I say to myself, they're subtracting 2. Well, what's the inverse operation of subtracting 2? Well, that would be to add 2 to both sides. Now, to go back to this concept a little bit, I'm going to change the screen here. Let me bring in this image of a science balance. Now, with this science balance, this is the equal sign. So on this side here, we have an equal sign right between the two plates. So on this left pan, I have a minus 2. On the right pan, I have 15, right? Now, a science balance is exactly like an equation. The green plate is exactly the same weight as the yellow plate. The a minus 2 is the same quantity or the same weight as the 15. Right now, it's balanced. But if, for example, I just added 2 over to this side and I did not do it over on the left side, well, what's going to happen? If I added 2 pounds to the yellow plate, well, now it's going to be unbalanced. The golden rule here is what you do to one side, you have to do to the other side. So in this equation now, if I subtract 2, add 2, they cancel out. All I have left is A. And on the right side, 15 plus 2 is 17. And again, they are still equal because I did the same thing to both sides of the equation. Now let's do another example here, and then we'll move on. Let's do one involving division. So say I have C divided by 4 is equal to 12. All right, I'm going to highlight the C. All right, I want to solve this now. I want to isolate C. And to isolate the variable C, I need to use inverse operations. So I'm going to ask myself, well, on the side of the equal sign that C is on, what are they doing? Well, they're dividing by 4. So what's the inverse operation or the opposite of dividing by 4? Well, it's to multiply by 4. And notice that I'm multiplying both sides by 4. Because what I do to one side, I have to do to the other. So on the green plate, I have C over 4. On the yellow plate, I have 12. And notice that I'm going to multiply this side by 4 and this side. Because what I do to one, I do to the other to keep the equation balanced. Now, if I divide by 4 and multiply by 4, inverse operations cancel each other out. So I have C left being equal to 48. Now, as I've mentioned before, we can easily check this equation, and I can put 48 in for C, and ask myself, let's see, 48 divided by 4, is that equal to the 12? And it is, so it checks out. Now these were called one-step equations. So the two examples, because the two examples I just went through, it only took one step to solve them, right? I only had to do something to both sides of the equation once. Now, two-step equations, as you may guess, it's going to take 2 times that I have to do something to both sides in order to isolate the letter. Now, there's a little flow of rules here that does apply. Now, let's review order of operations. Let's see, order of operations. Please excuse my dear Aunt Sally. So, for example, if I had 4 plus 2 times 3, I multiply first, and then I add. Okay? Multiplication and division come before addition and subtraction, right? Now, it's a little different when you're solving an equation. When you're solving an equation, you do all the addition and subtraction first, and then you do all your multiplication and division next, or last. Right? So it's a little different from the order of operations. Now I'm going to go through an example to show you why. Alright, so let's take a look at example 1. Now again, I'm going to, just to reinforce the idea here, I'm going to use my image here of the science balance. Alright, my equation here now is, make this a little bigger, maybe. Alright, here's my large science balance. Now, on the left side I have 2x plus 3 being equal to 11, right? Now, just like I did with the one-step equations, I'm going to highlight the letter. Now, I'm going to ask myself, what 2 operations are happening on the side that the letter's on? What are the 2 operations that are involved there? And if I look at this, let's see, what are they doing to x? Well, they're multiplying x by 2. What else are they doing to x? They're adding 3. So, what are the inverse operations of these two operations? Well, to solve this, I'm actually going to do the opposite. I'm going to divide by 2, and I'm going to subtract 3. Because one undoes the other. And going back to this, I always do my addition and my subtraction first. So I'm actually going to do this first. So I'm going to go up to my equation, and let's see, they're adding 3. I'm going to subtract 3 from both sides. And let's see, if I do that, let's see, if I add 3 and subtract 3, these cancel. So I have 2 x's left being equal to 8, right? Now I will do this one. Because right now I ask myself, let's see, what are they doing to x? They're multiplying by 2, so I'm going to do the opposite. I'm going to divide both sides by 2. Let's see, multiply by 2, divide by 2, they cancel. So x equals 4. My solution is 4. Now in blue down here, I'm going to check that. I'm going to go back to my equation at the top, and I'm going to substitute 4 in for x. So 2x means 2 times x, 2 times whatever x is, plus 3, and we're going to ask ourselves if that gives us 11. Let's see, now I do my regular order of operations. 8 plus 3, is that 11? It checks. So it works out. Now I want you to write down example 1 here in your notes, and I want you to work it out, pause this, and work it out so you have an example of this. All right, now that you have your first example written down in your notes, I want you to go to example 2, and I want you to copy this one down and work through it. Pause your recording as needed as I go through it. All right, one more problem. I'm going to use the science balance. And then we'll get away from the science balance, but it's a good way of showing how this all works. All right, so on one side I have 3x minus 4 equals 10, right? All right, now I'm going to highlight the x. I'm going to highlight the x. All right, now I'm going to ask myself, notice I'm not just doing this for the podcast. This is the thing that goes through my mind and anybody's mind when they solve equations. Let's see, what are they doing to x? they're subtracting 4, right? It's obvious to see they're subtracting 4. And they're multiplying x by 3. They're multiplying by 3. Now you might have to, on your paper, when you're doing these on your assignment or your test, you might actually write out what I'm doing right here. Now I'm going to ask myself, what's the inverse operation of subtracting 4? Well, it's to add 4. And what's the inverse operation of multiplying by 3? It's to divide by 3. So to solve this equation, I'm going to add 4. I'm going to do my addition or subtraction first, and then I'm going to divide by 3. So let's go through and do that. So I'm going to add 4 to both sides. Let's see, subtract 4, add 4, they cancel. That's why we do the inverse operation, to cancel out what's on the side the letter's on. And so what do I end up with here? So I have 3x being equal to 14. I've taken care of that step. Now I'm going to divide by 3, because right now they're multiplying by 3. If you multiply by 3, divide by 3, they cancel. Now, you can leave your answer as 14/3. You can leave it like that, because I can't simplify it. I can't divide 14 and 3 by any common factor. Now, some of you might be saying, no, it's not simplified, it's not written as a mixed number. Well, simplifying doesn't necessarily mean writing it as a mixed number. Now, we are going to go ahead and write it as a mixed number. Remember, you take top divided by bottom. And what do we get? We get our answer, and then the remainder over 3. So my answer is 4 2/3. Now to check it, we take 3 times, now this is kind of why I like to leave it as an improper fraction. So take 3 times 14/3 minus the 4 is that 10. Let's see, do our multiplication first. Notice I can cross cancel, right? And that leaves 14 minus 4, is that 10? It checks. I did it correctly. So, good problem. Make sure you've written it down and gone through the work on it. All right, let's do another one. Now this time I'm not going to use the science balance. Some of you are probably saying, that's real good. You might not have liked it, but again, it shows it pretty well. All right, I'm going to highlight the letter. What are they doing on the side the letter's on? Well, they're subtracting 2, right? And they're multiplying by a -2. So what are we going to do? Well, what's the inverse of subtracting 2? We're going to add 2. And what's the inverse of multiplying by a -2? We're going to divide by a -2. All right, let's go ahead and do this. I'm going to rewrite this so I have a little more room. Let's see, subtract 2, so I'm going to add 2 to both sides to keep that a science balance balanced. Subtract 2, add 2, they cancel, so I have a -2x equals 12. Now what are they doing to the letter? What are they doing to x? Well, they're multiplying by a -2, I'm going to divide by a -2. -6. And if you do your check right now, I want you to do your check. I want you to pause this and I want you to check it. And I want you to ask me in class if you do not get this to check. Now you should get it to check. -6 will work.